Attendees are in listen-only mode.
Hi everyone, this is Michelle Everson from the University of Minnesota, and I'm the current editor of the Journal of Statistics Education. And I wanted to welcome you to our March JSE webinar. Today we're very pleased and excited to have Alison Gibbs and Emery Goossens with us, and they published an article in the November 2013 issue of JSE about the evidence for efficacy of HPV vaccines, investigations, and categorical data analysis. And in a moment I'll hand things over to Alison and Emery, but I just wanted to remind you about how our webinars will work. As they're talking, if you have some questions, please go ahead and post those in the questions room, and then I can ask these questions of them when they're finished with their presentation. And there will also be a question and answer part of the webinar toward the end where you can raise your hand and we can unmute you and you can ask questions directly. So with that being said, I'm going to hand things over to Alison and Emery.
So thanks, Michelle. This is Alison, and hi to everybody who's joining us today. We're really grateful for the opportunity to talk about our work. Our paper is in the data sets and stories section of JSE, and over the years, JSE has been a great resource for me, and I particularly love the data sets and stories section, which I've used an awful lot and an awful lot of different articles from it in my teaching. So it was quite a pleasure to contribute to it, and I hope you find that our data set and story is useful to you in your teaching. So I'm here with Emery, and he was a student of mine a couple of years ago in a course that included generalized linear models. And at the time, he and I talked a lot about the importance of case studies to motivate what we were doing and the need for these case studies to be really compelling for the students. And out of that discussion, Emery came up with the data set and story that we're going to talk about today, and we thought it was worth sharing widely. So now I'm going to pass it over to Emery, who'll tell you some more about the data.
Thanks, Alison. Hello, everyone. So I'm going to talk a little bit about, the motivation behind why I chose this case study to sort of use for teaching statistics. So often I'm asked what kinds of jobs one can get with a degree in statistics. And I think that the answer to that is probably pretty obvious to most people in the webinar. But it seems that there's sort of a lack of awareness of how statistics can be used in the real world. Alison suggested that maybe I'm just hanging out with the wrong crowd, but I think that a case study is really, sort of provides an important example of statistics in practice. And I think that that's sort of an important concept to communicate to students. And while students might be aware of that statistics are used in clinical trials, I think that this case study sort of allows us to teach statistical methods as well as drive home their importance. More broadly, I think that this is a good case study because it really sort of hits on some important things in statistics as well. As I mentioned before, we are looking at clinical trials, and we look at a meta-analysis of a number of these clinical trials, which are all essentially experimental studies. And why that's important is because this is the type of study that sort of allows us to make causal conclusions. And I think that that's sort of the gold standard of studies, and we can sort of make these causal conclusions that are quite important in the real world. What's also nice about this case study is that we look at a number of data sets from a number of clinical trials, and so this sort of drives home the point that there's an inherent randomness or differences in different data sets, although maybe we're measuring the same outcome. Another important concept, I think, is that clinical trials themselves are sort of carried out in many stages. So the idea of verification and validation of results is important to drive home because, unlike many other case studies where you might only have one data set and you can make sort of conclusions about that data set with statistical analysis, this sort of emphasizes that, in practice there's often many stages to statistical analysis and making conclusions that we can act upon. So a little about the data that we are using. As I said before, this data is collected from a meta-analysis of the effectiveness of HPV vaccines in clinical trials. This meta-analysis consists of 7 clinical trials. We use 4 of these, and we look at perhaps not an obvious outcome of persistent infections in these clinical trials in follow-up with the organizers of the clinical trials. And the reason why we did that was because it sort of allowed us to compare a number of these studies with a common outcome. And whereas we might have looked into cervical cancer outcomes, persistent infection was sort of this common thread between a number of these studies, and that's why we chose this. So I'm going to pass it back over to Alison, and she's going to talk about a bit more of the specific statistical methods that we can use.
Well, thanks, Emery. So in addition to what Emery just mentioned, I really like teaching with this case, which I've done a number of times, because there's really an opportunity to discuss lots and lots of different things, including experimental design issues, the importance of randomization, lots of ethical issues to discuss, which I really like finding opportunities to do that. There are issues, if one really delves into this, about whether to consider the data that are the intent to treat or the per protocol data, and so on. So lots of other issues. But what I'm going to focus on now is more statistical issues. There is a lot of things within these data that create really rich teaching opportunities because of the statistical issues that arise, or comparing results from different studies and so on. So as Emery mentioned, the data came from this meta-analysis, and the meta-analysis is just full of many 2-by-2 contingency tables, where the 2 factors are what group the subjects were randomly assigned to, the control or the vaccine group, and then whether or not they acquired an HPV infection. And some of these contingency tables can be combined to do other analyses, and some can't, and that's something we'll talk about in a little bit. And there are many different methods, depending on what you're teaching and who your audience is, that you could use these data for. So, of course, for any 2-by-2 table, we could do inference for 2 proportions, or a chi-square test, or randomization test, or Fisher's exact test. With more mathematical students, I've used them for a multinomial likelihood ratio test. And then for more advanced students, like the course that Emery was my student in, I've used these data for as an example of both logistic regression and log linear models. And then these ones I grayed out here aren't that it's not that they're not important why they're grayed out, it's just I haven't actually used these data for studying odds ratios or relative risk or meta-analysis, but if you were teaching a course where those topics were covered, these data, of course, are suitable for that as well. And as I mentioned, there's a lot going in. There's a lot of things going on with these data because they come from different studies and because different outcomes are considered, that create these rich teaching moments because of some statistical issues that arise, and that's mostly what I'm going to focus on for the next little bit. And now, well, I guess in order to do that, I better first set up the 2 research questions that we consider in the paper and today, which is, well, essentially these boil down to, does the vaccine work when it's supposed to? So does it provide protection against infection when the vaccine includes virus-type particles that it's supposed to, of types, I guess, so does it protect against the types of virus-type particles that are actually in the vaccine? What I learned over the course of this case study is that there are actually more than 40 types of HPV. And any one vaccine covers maybe 4 of these types of HPV. And so an interesting other question is, does the vaccine, or do the vaccines also provide protection against these other types of HPV? And we'll look at both of these research questions as we go. So let's start with the question, does the vaccine work when it's supposed to? And here's an example of 3 of those 2-by-2 contingency tables I was talking about. They come from 3 different studies, the Harper, Kutsky, and Patricia studies. In the tables, we just have counts of the number of subjects that were randomly assigned to either the control group or the vaccine group, and then the question of whether or not they acquired an HPV infection by the end of the study period. And then the mosaic plot to the right illustrates these data. So the height of the bars indicates the number of studies or the number of subjects in each study. So something obvious right away is that the Patricia study was much, much larger in the number of studies, or the number of subjects rather, than the Harper or Kutsky studies. The blue represents the subjects who did not acquire an infection, and the purple is for the subjects who did acquire an infection. So we can see right away that, number one, the vaccine isn't perfect. There are subjects in the vaccine group who acquired an infection, but the number of subjects who acquired an infection is much larger in the control group than the vaccine group, and that's true for all 3 studies. Something else you might note is that there's something going on in the Kutsky study. For some reason, there was a much higher infection rate overall in the Kutsky study. Regardless, for all 3 of these studies, the analysis, whatever type of analysis you do on the individual 2-by-2 tables, all highly significant, showed really strong evidence of a difference in the infection rates between the control and the vaccine groups. So these statistical, some of the statistical issues, I guess, that arise, that there is also opportunities to discuss. And I really actually like the fact that here's 3 studies, same context, same question, but not necessarily quite the same results, and there are issues we can talk about why that happens. For example, in the Harper study, it's the smallest in terms of the number of subjects. And as a consequence, in the vaccine group, only 1 subject acquired an infection. So if you're relying on the asymptotic methods to analyze the data in this contingency table, you might have a problem. So what can we do? And we can see from these data that here they are essentially studies of the same thing, and yet we have this issue in one study and not in others. The other issue I'd point out that's also related to sample size is that the Kutsky study is the study with the largest difference in the proportion of subjects who were infected between the control and the vaccine groups. It's about 14% in the Kutsky study, and it's 4 or 5% in the other 2 studies. But yet, the study that has the strongest evidence against the null hypothesis of equal infection rates is in the Patricia study, which of course is the consequence of the very large sample size in the Patricia study. I think it's important to emphasize these issues about sample size and power every opportunity we can. Just really recently I've had a few different colleagues from other departments around the university tell me that in our statistics courses we need to spend more time talking about power, because there seems to be an awful lot of awareness in other scientific disciplines about studies that are being carried out that are underpowered, and there's a lot of concern that students don't appreciate that. So I love that we've got an opportunity here to see the effect of sample size and power in action. Of course, these are all experiments, so we can make the causal conclusion for all of them that indeed it is the vaccine that's causing the differential infection rates. And then we can ask the interesting question, even though infection rates aren't that high, maybe our students would like to consider, is this really enough evidence to argue for widespread provision of the vaccine? And our students are probably the first generation who have grown up with widespread provision of the vaccines. They might want to consider how strong the evidence was that went behind that policy decision. And I mentioned earlier that some of the 2-by-2 tables can be considered together, and perhaps we could do that here by adding a third factor, which is study, and then we'd have a 2-by-2 by 3 three-dimensional contingency table. In that way, we could investigate whether the difference that we're seeing between the infection rates in the treatment and control groups actually does differ among the studies in a statistically significant way. The first time I went to do this, I was dealing with a group of students whose level of sophistication in the types of analyses they could do stopped at two-dimensional contingency tables. So I couldn't do a three-dimensional contingency table. I couldn't do logistic or log linear regression. So I thought, well, let's look at this for the control group and the treatment group separately. So for the control group, we constructed a 2x3 table of the outcome, infection or not, versus study to see if the infection rate differed across study. And as I shown here, there was really strong evidence, very tiny p-value of different infection rates across the studies. And then we did the same thing for the treatment group. And for the treatment group, there was only weak evidence, if possibly no evidence, depending on how strict you want to be with your cutoff, of different infection rates across studies. And I thought, well, no, this is interesting. It reminded me of a really common interpretation error that I've seen multiple times in my consulting work. And I think it's a consequence of misinterpretation of large p-values, where people sometimes treat them as if it's evidence for the null hypothesis, so that it's actually evidence supporting no difference. A more typical example where I've seen that is some research colleagues who've done analysis, say, of change from baseline in the treatment group, and maybe that's significant, and then they've also analyzed change from baseline in the control group, and that's not significant, and then they want to conclude from that that there's a difference between the treatment group and the control group, but yet they haven't actually done the analysis that considers that. So in this case, if we want to say the corresponding thing, that the difference in infection rates between the treatment and control groups differs among the studies, then we need to carry out an analysis that includes that interaction. So we need a little bit more sophistication, which brings us to the logistic regression or log linear models. And here's the results when we do that. From the log linear models on the 2x2x3 table, there's no evidence of the three-way interaction, so it's the partial independence model. So that interaction that I talked about, the difference in the infection rates, is not significant across studies, but they're very large p-values. And logistic regression gives the same conclusion. If you're looking at the plot to the right of the log odds of HPV infection for the control and vaccine groups for the three studies, it's probably pretty obvious that the interaction is not significant, despite the analyses that I talked about previously when I looked at the control group and the treatment group separately. I also really like, if you've got a course where you do log linear models and logistic regression together, to put the two analyses side by side, because one way you're looking at a three-way interaction and one you're looking at a two-way interaction. And I find first time that kind of students find that really difficult, and it's really good to sit down and make them grapple with the fact that they're really getting consistent results that are consistent with each other. I might note here in this analysis, we can't make causal conclusions, of course, because subjects aren't randomly assigned to the various studies. So this analysis is a little bit different than the analysis on the 2x2 tables that I talked about in the previous slide, where everything was pure randomized experiment. And now turning to the second research question, which is, does the vaccine work in situations that it's not really designed for? So does it provide protection against infection with types of HPV that aren't in the vaccine? And here I picked two types of HPV. These are two of the most common types, excluding the ones that are in the vaccines that are currently being used, HPV 31 and 45. And these data come from a study called the Future 1 study. As Emery said, there are a total of 7 studies in the meta-analysis, so there's lots to pick and choose from. And if you just look at the numbers in the table, or equivalently look at the plot of the log odds in the control and the vaccine group for each of the 2 HPV types, it probably won't be surprising to you. Let's see, here are the p-values, that we see a statistically significant difference with HPV 31. So the vaccine seems to be providing protection against infection with it, but not a difference with HPV 45. And as we did previously with the three 2x2 tables I showed earlier over the 3 studies, we might think, well, let's combine these tables, maybe do a 2x2x2 analysis so that we can investigate if there's evidence of an interaction. So put this together and say, you know, is there evidence of a differential level of vaccine protection between the 2 types of HPV 31 and HPV 45? And hopefully if you ask your students to do that and they start thinking about how they carry out this analysis, they might realize, hey, we've got a problem here. Looking at the data as a 3-way table that I've got on the screen now, these observations aren't independent. It's the same 1,000, couple thousand, I can't remember the exact number now, but the same 2,000 or so subjects in the left-hand table for HPV 31 as in the right-hand table for HPV 45. So they aren't independent. Moreover, another thought might be, well, maybe we can collapse this to a 2x3 table where one factor would be control versus vaccine group, 2 levels, and the factor with 3 levels would be no infection, infection with HPV 31, or infection with HPV 45. And the problem with that analysis is it's actually quite clear when you look at the numbers that there are subjects who acquired both an HPV 31 and an HPV 45 analysis, and we can't sort out who those people are. And so that's a problem as well for this. So what we have here is an opportunity to force students to grapple with another assumption in analyses that they're carrying out, which is that they require independent observations. And I really like having this opportunity and to talk about it whenever I can, because I don't feel like we talk about it enough, and especially in our elementary courses. All of the analyses that we typically teach has an assumption of independent observations, and we tend to protect our students from data sets that don't have independent observations, so they may not realize how important of an assumption that is because they don't have any experience with it, but yet it's probably the most important assumption in terms of choosing an appropriate analysis to carry out on the data. So now I've talked a bit about the analysis and statistical issues that we can see from these data, and I'm going to pass it back to Emery now to give a bit more context to what we've seen.
So another great feature of this case study is that these were actually clinical trials that were carried out. It's not just some toy example, and so there's a plethora of information regarding these clinical trials that we can use to add some context to the statistical methods that we teach. So as I said before, there's a number of important concepts that we can bring up, such as the need for further validation. And you can see this in this chart. We have 2 sponsors, 2 companies that worked on these clinical trials, and we see that in the Harper and Patricia studies, which as you may recall, the Harper was a much smaller study and the Patricia was a much larger study. We can see that in 2003 to 2004 was when the Harper study was carried out. The subjects that were enrolled were from North and South America. And then later in the Patricia study, which was much larger, which we see was most likely a sort of a validation of the initial experiment, that the subjects were enrolled from various regions all over the world. Again, and this is borne out as well in the Kutsky and Future 1 studies, where again it was Mark that was involved in both of these. The Kutsky trial happened first, and the Future trial later. And we see that also there's also a change in the experiment in terms of what virus-like particles were included in the vaccines, using only HPV 16 initially, and then later using HPV 6, 11, 16, and 18. So I think that this is this sort of brings home another concept that in many ways we can't, we have to consider these factors in our experiments that, can we really extrapolate the results of the Contingency trial that was only enrolled subjects from the United States to the entire population? And I think the answer to that question is no, and that's obviously why Merck in their later clinical trials enrolled women from all over the world. I think that this would be useful as sort of a, to discuss these issues maybe after the statistical analyses have been taught, to sort of give an idea of what is involved in actually using statistics in the real world. So just to conclude, a few points to sum up the presentation. Clinical trials are a relevant and real-world example, and I think that they really show that studying statistics matters to students and to the population that are receiving these vaccines. I really like that there's one story, one context, but there are many data sets which you can do various analyses, from basic to more advanced topics. And also, as I mentioned before, the added context really sort of adds to a discussion of what statistics is in practice, and how we should think about things like experiments and random sampling or enrolling different subjects around the world, and how we can use these results to extrapolate or not to extrapolate to other populations.
Okay, and I guess now we'd be happy to take any questions you have. There's just the papers, our JSE paper, as well as the original paper where that data came from.
Well, thank you so much, Alison and Emery. Right now we don't have any questions yet, but if you have some questions, please go ahead and type them in the questions box, or if you want to raise your hand, I can always unmute you and you could talk directly to our speakers. I actually had a question. I'm just kind of curious as to how your students respond to these examples. Do they seem interested in them and really engaged in them?
Quite a bit. University of Toronto has a large medical school, and an awful lot of our subjects are focused in life science areas. So I find they tend to eat up life science and medical examples pretty well. But I also find that students appreciate, modern research, because you start by asking, how many got an HPV vaccine, and I, certainly I didn't growing up. What happened, what changed, why did this develop, how would you develop a vaccine, how would you choose to make a policy decision? I mean, in Toronto, every grade 8 girl gets an HPV vaccine in grade 8 in schools, provided free of charge. So that's an expensive policy decision, and how one would get to that point, I think students find that an interesting question.
I was also kind of curious about how you assess the effectiveness of some of these examples. Do you have maybe homework assignments where they have similar types of problems that they have to investigate, or questions on exams that are similar to these types of questions?
Yeah, that's one of the things actually we really love about this data set, because you go back to the paper, or even our JSA paper, we just present some of the data, but there's so many possible sets, those little 2x2 tables that one could pick out and ask the students to do the analysis on them as well. So if they can apply, whatever messages you wanted them to get from the examples you did with them, and then here it is, same context, so they don't have to grapple with the context again, yet different data.
Oh, we have a question here. I'm going to unmute. Oh, wait. Maybe no. Someone raised their hand and then unraised it, so maybe that was a mistake. Well, we'd love questions. If anyone has any questions for Alison and Emery, again, please post them in our questions room or raise your hand and you could talk with them. It seems like we have a quiet audience today.
Yeah. Everybody from the north is just tired and sick of winter, I think.
I think so. I think so. Well, it doesn't look like we have any additional questions. I guess you did such a great job answering all the questions during your presentation. Oh, wait. We might have one here. Okay. So one question that came in is, what are your favorite applications for introductory students with this data set?
So I guess in our first half course, the only real thing we do is inference on two proportions.
Mm-hmm.
So I guess it's pretty clear what one can do with that. So I've used it multiple times in that setting. I like it because it's, for many, many, many years I used either the Salk polio vaccine trials or the physician's health study data. And we were talking earlier about examples that are compelling to students. This is much more connected to their personal experiences. So I quite like having the ability to use these data instead with them.
Mm-hmm. Well, it looks like we're out of questions. So I wanted to thank Alison and Emery for your great presentation and for your willingness to be here to share your work from JSE. And I wanted to also make a couple of quick announcements before we end this webinar. The March 2014 issue of JSE will be coming out soon. Our goal is to have that online by March 28th at the latest, so please be on the lookout for that. And also I wanted to mention that the electronic conference for teaching statistics, or ECOTS, will be coming up soon in May. And very soon, hopefully today or tomorrow, we will have the registration system up and running for ECOTS. So we hope that you'll join us for that conference. And we don't have a JSE webinar scheduled yet for April. There may be something, so be on the lookout for that. We'll let you know as soon as we can. So thank you again, Alison and Emery, for being here today.
Thank you.
And I will end the webinar, so thank you all for joining us this afternoon.